Okay, this one is the schematic illustrate the step growth phenomena for a system of 12 monomer molecule. Okay, as we can see in A, involve the monomer A and B, and the monomer molecule containing functional group A and B. Okay, contohnya monomer ni dia ada functional group A dengan B. And the AB group reacted to form an AB linkage. So dalam kotak ni dia akan produce AB lah, dia react, dia akan AB, AB, AB kan. Okay, step ni dia step growth polymerization, it happens step by step. Okay, so we assume that in step B, half ataupun 50% conversion the monomer molecule are consumed. Means that it has been a reaction happens between the two functional group. And in step C, almost 75% conversion of the monomer molecule are consumed. And the step D, we have 100% conversion of the monomer molecule reacted, but each polymer or oligomer molecule still has reactive end group. Hence, the polymerization reaction will continue in stepwise fashion. Okay, this one skip tetramer. Okay, ini pun dah. Alright, we proceed with the polymerization kinetics. So polymerization kinetics, we follows the Floris assumption. Okay, Floris assumption that defined as the reactivity of a functional group is independent of the length, size of the chain molecule to which it is attached. Okay, so Floris assumption dia propose that reactivity dalam setiap functional group tu dia tidak bergantung kepada size panjang ataupun lebar molekul dalam setiap monomer tu. It has two assumptions, whereby the assumption 1 means that the reactivities of both functional group of a bifunctional monomer are the same. It means that untuk functional monomer, untuk bifunctional monomer, which is dalam satu monomer yang ada dua functional group berbeza tu, reactivity dia kita consider sama untuk dua-dua monomer dalam satu, untuk dua-dua functional group dalam satu monomer tersebut. Okay, so assumption 2, reactivity of a functional group is unaffected by reaction of other functional groups in the molecule. Yang ni kalau kita ada lebih daripada satu monomer, maknanya reaktif kita assume dalam step growth polymerization ataupun Floris assumption ni, reactivity untuk setiap monomer tu dia tidak mempengaruhi reactivity dalam setiap functional group dalam setiap monomer, dia tidak mempengaruhi reaction lah kan. So maknanya kita consider reactivity dia sama je semua. And the concept of equal reactivity of functional group, inilah maksud dia. Kita consider as the equal reactivity of all the functional groups in the reaction. While more complicated situation can occur, we will consider only the kinetic of simple polyesterification. And the kinetics of most other common condensation follows an analogous pathway. Okay, we have the catalyzed step growth polymerization and uncatalyzed self-catalyzed step growth polymerization, which is type 2. Now we are in polymerization kinetic. We will study the kinetics of the polymerization. Before that, we look at the relation between the chain length and the extent of reaction. Okay, extent of reaction is given by the P. Okay, P ni dia banyak nama. Kita boleh panggil dia sebagai extent of reaction, kita boleh panggil dia sebagai reaction conversion. Okay, the characters develop a simple equation for relating dP, which is degree of polymerization, to % conversion of monomer for type 1. So again, what is step 1? Step 1 is the polycondensation, which is catalyzed step growth reaction, di mana dia involve presence of the Dia react dengan air kan. Reaction tu dia react dengan air balik. Dan dia involve more than two monomer. Dia involve polyfunctional. Okay. So if one assume that there are NO molecule initially at time equal to 0 and N molecule after a given reaction time which is T equal to T, then the amount reacted is N naught minus N. So N besar, N naught is a original number of molecule present in monomer A, B. Okay, for N besar, it is the number of all molecule remaining after time. And the reaction conversion P equal to 1. Okay, P equal to 1 and it cannot be more than 1. Bila P equal to 1 means that it reached 100% conversion. Means that all the monomer has been transferred or has been consumed to produce a polymer. And P is given by the reacted functional group in a mixture divided by total functional group of monomer at time, which is equal to 0. Masa mula-mula reaction lah, maknanya sebelum reaction tu berlaku, kita bahagikan dia dengan semua total functional group dalam tu. The relation between chain length and extent of reaction lagi P chain length and extent of reaction. The reaction conversion P is then given by the expression P N naught minus N divided by N naught. So N equal to N naught 1 minus P, and dP is N naught over N equal to 1 over 1 minus P. So dP sama dengan Xn. Saya kena tulis ni, tapi payah juga nak tulis ni. Tak apa, sekejap lagi saya tulis. Alright, this one is the graph to represent as a degree of polymerization increase. Okay, degree of polymerization is given by the Xn. It will increase the molecular weight of the polymer. So, if the conversion increase, okay, P increase, the degree of polymerization also increase, and it will produce high molecular weight polymer. Kalau slow macam mana? Kalau dia sangat slow, kita kena letak catalyst. Okay. So in step growth polymerization, the monomer concentration will drop or will decrease rapidly in the early stage of reaction. And macam mana kita nak dapatkan high molecular weight? Kita kena increase dia punya concentration. So in step growth, dia involve a dimer, trimer, mostly involve a random reaction. Now I'm giving you an example of the question that we'll be asking in the final exam. For example, the question asks you to describe the relation between Xn with P. So, as we all know, Xn is equal to 1 over 1 minus P. So, awak tak perlu nak tanya kenapa macam ni, dia memang dalam saintis kita buat equation ni. So, memang kena tahulah, kena ingat Xn equal to 1 over 1 minus P. So, how can it is derived? Okay, how can this equation derive? So, as we all know, Xn is equal to dP. Nama lain Xn sama dengan dP. dP is degree of polymerization. Okay, Xn pun degree of polymerization equal to N naught over N. So, N naught is the original number of molecule present in monomer. Present dalam satu monomer yang ada dua functional group. And N besar tu adalah a number of molecule remaining after reaction time equal to T. And kita tahu juga P extent of reaction sama dengan N naught minus N divided by N naught. So kita keluarkan P N naught over N naught minus N over N naught. So N naught over N naught dapat 1 minus N over N naught ni, yang ni lah kan. So kalau kita terbalikkan dia, jadi 1 over Xn kan. Ni algebra ni, mesti terror semua kan. guna balik fungsi yang awak belajar dalam calculus yang, apa nama, bukan calculus, dalam calculus lah kan. Pre-calculus awak tanya, awak kata macam tak ada guna belajar tu kan. Ni lah guna dia. Kalau awak jadi saintis esok-esok pergi kerja dekat petroleum ke, benda ni lah yang awak akan guna nanti. And P minus 1 terbawa ke sini balik sama dengan negative 1 over Xn. Therefore, we get Xn equal to 1 over 1 minus P. Question asks you to calculate the degree of polymerization. Okay, let's say if they give the value of P is 98%. As we all know, P is equal to 1. Okay, 1 means that 100% conversion. So, Pxn equal to 1 over 1 minus P. Kita tukar, dia tak boleh lebih daripada 1 kan. Dia sama dengan 1 ataupun kurang daripada 1 lah. So, 0.98. Bahagilah kan, dapatlah 50. dP is usually not high. To obtain very high molecular weight, we use very pure monomer. Okay, monomer yang awak nak guna untuk produce polymer mestilah pure. Dia tak bercampur dengan other things like water and so on, other materials. And we must use an exact stoichiometric ratio. Means that the number of mole in the monomer must be correct. Okay, jangan tak balance. Kalau dia tak balance, dia tak akan produce high polymer. Maybe dia tak produce tu maksudnya dia still produce polymer tapi dia tak achieve 100% conversion or 99% conversion. Maybe it just reach at 70% or lower than that. And Xn is the number average chain length divided by number of repeating units. Okay, nanti try do the exercise 1, right? Okay, this one still in the relation between the chain length and extent of reaction. This one is for type 1. Okay, kalau type 1, Xn sama dengan N0 over N. Kalau type 2, it has a different equation, which is the half of the number of monomer, a number of functionality in first, macam mana nak cakap? Macam ni, untuk type 2 dia involve bifunctional kan. So dalam bifunctional dia ada dua functionality. So Na untuk functionality pertama, Nb untuk functionality kedua dalam satu monomer tu. Divided by N. Okay, number of all molecule remaining after reaction. C ni concentration of one of the functional group after a fraction P have reacted. Given by C equal to C not bracket 1 minus P. Okay, kalau type 2 dia ada separuh-separuh macam ni. Okay. Now we look at the type 1 catalyzed polymerization. For example, polyesterification with the addition of strong acid. So based on the assumption that the polymerization kinetic are independent of molecular size, the condensation reaction may be all simplified as, okay, macam ni lah, COOH, OH, dia akan produce polyester. So the polyesterification reaction is catalyzed by acid and the mechanism is given, okay, is given by dia carboxylic acid react dengan acid kan, carboxylic acid yang ni react dengan OH kan. Kalau catalyzed reaction ni kita letak strong acid dalam ni, dalam reaction of polyester. Kita nak bagi cepat. Okay, now kita tengok kinetik dia macam mana kalau kita letak acid. First one, in the step 1, it is involve the fast equilibrium. Bila ada acid COOH ni, dia akan jadi reversible reaction to produce a protonic acid. And in the step 2, it involve the nucleophilic attack, which is slow rate determining step with the OH. So the reaction of protonic species will react with the diol structure, which is the monomer, second monomer. And